So I think it seems the computer time is correct now. So we'll be recording. There might be 2 people that may join us remotely. They're not here yet, but they come, we admit them. You must have seen your final scores on the quiz. Any concern? So I'm open to reviewing your assessment at any time. So if there's any quiz or meeting that we took and you don't feel comfortable about your grade, just let me know. We can look at it together and find out what's, send this and try to show you that resolve it. All right. So, and again, as I said last class, if you are concerned about your current grade, don't worry about that. You have opportunity to replace it using your midterm. The midterm will cover section 1 and section 2, which we are starting today, or which we started last class, right? So if you do well on midterm and you want us to use your midterm to replace your grade on this one, we can totally do that. Okay. So you still have opportunity to cover whatever went wrong. All right. So today we continue with I think I should be sitting close here so that the volume could come out. Today we'll continue with binomial distribution. So hopefully everything on the technology works well so far. So last class we tried to introduce some of these concepts. I just outlined them here so that we can stay highlight them again, right? We said that a Bernoulli trial is any event that has 2 outcomes, right? Any event that has just 2 outcomes. And we gave some examples. I don't know if you could remind us of those. It's we rain or it will not rain. That is 2 things. If I flip a coin, it's either head or tail. That is 2 outcomes. Anybody remember any other one? Any event in real life that could only have just 2 possible outcomes?
Getting a question wrong or right.
Getting a question wrong or right. Right. Multiple choice question, you click the correct or you get the wrong one. Okay, so let's now wait a minute. Let's continue. So when you have several of these, right? Several Bernoulli trials is what gives you a binomial distribution. Right. So another way to describe the mass and the button. Another way to describe a binomial distribution is to look at it as several Bernoulli trials. So if you have many of the Bernoulli trials, you have a binomial distribution. Okay, so we talked about some of the properties of binomial distribution last class, and we're going to repeat some of them again. The first one here is independence. We did explain that or describe that as the fact that each event happening does not affect the next one happening. So if I get a coin and I flip it 5 times, each flip, whether it comes out head or tail, has nothing to do with what comes out on the next flip. So we say those 2 events are independent, right? Yeah. So if anything I write is not clear, just let me know. I can rewrite it. My handwriting could be okay. So that is independence, and what that also implies is that the probability will be fixed, right? So if I flip a coin 10 times, the probability of getting a head is always 1/2. Always, it can't change to any other thing, right? So in binomial distribution, in Bernoulli trials, the probability is fixed. So that is one property to take note of. All right, it doesn't change. Okay, so if, for example, I say, what is the chance of getting a head at the 3rd throw when I throw a coin once? Is 1/2. What is the chance of getting a head at the 20th row, it's still 1 over 2. The probability wouldn't change. Okay? So you see some questions on the homework to just test these concepts. Then the next thing we talked about was that the fact that they are complementary, right? And somebody helped us to describe complementary as the sum being equal to 1, right? In binomial distribution, we talk about success and failure. So success will denote the desired outcome. If I'm flipping a coin and my desire is to get a head, then head remains as, so becomes a success. If I'm flipping a coin and desire is to get a tail, tail becomes a success. So success is described as the outcome you desire. Okay. The other one is the failure. So we said the two added together, the probability of the two, not the two, right? The probability of success and probability of failure added together are complementary. That means they will always sum up to 1. Okay. Again, you see some questions in the homework to test for that knowledge. So generally, we represent success with P, the probability of success with P, the probability of failure with Q, and this will always sum up to 1. Okay. Another thing else we said was that if this equation is true, then it also implies that Q could simply be calculated as 1 minus P, right? Put in that. And then maybe lastly to note here, the number of events N starts from 0. So that is a common mistake when you're calculating equations in binomial distribution. You must start from 0 because 0 is possible to happen. So if I'm thinking about flipping a coin 5 times and my interest is to know the number of heads that 5 flips, I could get 0 heads, right? So there will be 0 success. So but the temptation is to start counting from 1. So watch out for that when you're solving questions under this topic. So N, the number of events, number of successes, I think I should write it differently. Maybe we should say, make sure we're using the right notation. Let's say N of X. Okay, so number of successes starts counting from 0. So if all these are taken into consideration, we could go ahead and develop a formula as we did last class, right? And so if we say, for example, that X is a random variable, so I'm using this arrow to me implies a random variable. Right, and can anybody tell us something about a random variable? What is a random variable? Any ideas or suggestions? How would you describe or define a random variable? So it's just anything that changes. So in statistics, when you're collecting data, you assign it to a variable. So for example, if you want to collect data about everybody's quiz score, I could call that variable quiz, right? And it is a variable because it changes as we move from one person to the other. So it varies, right? And it is random because the way it changes is not predictable. It could go up, it could come down, depending on who I am working on at that point in time, right? Height, for example, if it's a data I'm interested in, will become a random variable. So the variable will be height, and it's a random variable because as I move from one person to another, it changes in a random way. Okay. So if X, capital letter X is a random variable, and small letter x denotes subset, okay, we could write that let me change color. We could write that probability of the random variable being equal to a given measure of success will be denoted as N combination R S. Okay. Now we're going to explain this more. probability of success raised to the power of x multiplied by probability of failure raised to the power of n minus x. Okay, so product in between. And we were trying to make this formula simpler last class. So we're going to write different versions of the same formula. So this could be written, if I expand it a little bit, you'll find this in some textbook. It will denote that combination this way, right? This is like n choose x multiplied by p power of x. And if I may expand q at this time, I can write q as 1 minus p, as we saw earlier, right? And then n minus x. These are all ways to make the calculation easier, since we are calculating by hand. And then if we go on further, we can replace this combination here with n factorial divided by n minus x factorial multiplied by x factorial. Then we continue times probability of success raised to the power of number of successes and probability of failure raised to the power of number of failure, right? N minus x will denote number of failure, because if x is your number of successes, and we know that if x is number of successes, right? Right, in that case, it will imply that n minus x will be equal to number of failures. Right, knowing that n represents number of trials. Okay, so what this is simply saying is, I mean, if I flip a coin 5 times and getting a head is my success, then I got 3 heads, which means I have 3 successes. If I want to know the number of failures, then I'll remove 3 successes from the number of time I flip the coin. All right, so n x will give number of failures. So if I flip the coin 5 times and I got 3 heads as my success, the number of failure will be 2, because 5 minus 3 is 2. Right? Okay. So that is all you have in the formula. So I'm trying to make this conceptual as possible, like, so you'll be able to remember it without memorizing. Yes.
So if you put, like, in the second equation that you put up there, what do you do with the n over x? Like, say it was like 3 over 2.
Yes. So
do you divide it, or do you, like, what do you do with that in the equation?
right. So this is just a symbolic notation. Right, it means okay, so this sounds like it means the same thing as this expression here. This is also a symbolic notation, right? This expression simply is trying to factor out how many combinations that you can get from getting number of successes. So for example, if I have, okay, so if I say I flip a coin 5 times and I got 2 heads, those 2 heads could come from any series of arrangements. I could get tail, 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 head, head. That's 2 heads out of 5 flips. I could get head, head, tail, tail, tail. That's the 2 heads. Like, it could be in any arrangement, right? So in making this computation, we don't care about the arrangement. We don't care when the head happened. But the key thing we're focused on is that there were 2 heads out of the 5 flips, right? So what this aspect of the formula, the one I put in curly bracket in black, is trying to do is to compute that number of different arrangements, right? Okay, so that if somebody says, I have 5 heads, let me write there so that, let me go to the board. Then it's published. So if someone says, I have 2 successes, right, out of 5 flips, then I could have head, head. If head is my success, tail, tail, tail. I could have head, tail, 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 right? continue this combination, if I do it sequentially, I'll get as much as possible. So that's what this part of the equation, the one in curly bracket, is trying to do. So you are not dividing, you are simplifying it this way. Okay, so that is why we have this other second equation. So this is how we are going to solve it. So this n choose x or n choose x is simplified as this. And last class we were working on this, and somebody helped us with what that exclamation mark means mathematically, right? Factorial, right? So to answer your question, this item here, sorry, that item that you asked about, right, is simplified this way. Okay, so you can see the rest of the formula remains the same, essentially. So we just expanded that. So let's go ahead and do an actual example to kind of give meaning to that. Okay. So we're gonna come back to this, but I'm gonna skip to the second example because it has something that will help us solve. So let me move this forward. So assuming we have a scenario where a fair die is rolled 10 times, and we are interested in finding the probability that 6 shows up, all these different kind of arrangements, right? So think about this, and can somebody explain why we should use binomial? Like, how do you describe this? How does this become a binomial distribution? We said binomial distribution are distributions that has only 2 occurrences, right? True or false, good product or bad product, rain or not rain. Got a question right or failed it, like there must always be 2 outcomes. So, but a die has 6 sides, right? So how come we are going to solve this with binomial distribution? Any idea why we should do this with binomial distribution?
It's only asking about 6, so it's either 6 shows up or it doesn't.
Exactly, right? So whenever you flip, your interest is not any other number but just 6. So there are only 2 possible things that could happen. It's either 6 shows up or other number shows up. All other numbers are classified as one event, right? So you have 6 or not 6, right? So that makes it 2 outcomes. That makes it a binomial distribution. So we can apply that formula to solve it. Okay, very good. So let's do the first one. So for question A, we are interested in getting, so here our success is 6, right? If 6 shows up, then we have a success. If 6 doesn't show up, we have a failure, right? So automatically you know that your x is equal to 6. Okay, and so a good idea would be to just write down the components of those formulas, what their values are, and then just plug in. Right. So n here will be equal to. What do you think n will be in this question? 5, 10. Okay, so I actually made a mistake in the first one. N should be 10, right? X is the number of times that we have successes, right? X is number of successes. So X should not be 6, X should be.
Unknown.
Huh?
Is it unknown?
Is it what?
Unknown, because if we don't know how many successes there are yet.
Okay, yeah, but so that is what we are being asked. We are asked, what is the probability that 6 shows up exactly 5 times?
So then it's 5.
So we know it's 5. Okay, so then we think about our probability, right? What is P here?
1 6.
1 out of 6, because there are 6 sides, and we're interested in just 6 showing up. And so there's only 1 6 out of the 6 side of the die. So our probability here is 1 6. So you're going to see this. These are the key things that will determine whether your answer will work out well, right? So for each question, you want to figure out what each this component of the formula means, right? And for each question is going to change. right? If I talk about coin flip, for example, the probability will change to 1/2, right? Because there are only two sides to a coin, and so on. Okay. Then if P is 1/6, Q will be equal to
1/6 minus, no, 1 minus 1/6.
1 minus 1/6. So remember that Q is 1 minus P. So you're doing 1 minus 1/6, which will be 5/6, right? Very good. So and you can put these things in decimal form. That might make it easier to work. If you want to do the in fraction, that is also fine. Okay, so now we've got every piece of that formula. We go ahead and plug it into the formula to answer that question. Okay. We know that if X is a random variable, which is like the universe of all possible outcomes, and we're interested in getting 5, okay, then we're going to use the expanded formula. A probability of doing that is n factorial divided by n minus x factorial divided by x factorial times probability of success raised to power of number of successes times probability of failure raised to number of failures. Okay, so we can plug in into this. We plug into this equation, we get about 10. So we have 10 factorial divided by 10 minus 5 factorial, right? Divided by 5 factorial times probability of success is 1/6, and we're raising this to the power of x, which is 5. And its probability of failure is 5/6, and we're raising this to the power of n minus x, which will also be 5. Because n is 10, x is 5, so we still get 5 there. So we've plugged into the formula successfully. The next is to simplify it. This is 6, right? So last class, we learned that factorial, I just multiply the number, how many times you have it, right? So 10 factorial will be, starting from 10, decreasing to 1. So 10 factorial will be 10 minus 9, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you're going to figure out easier way to do this, but I'm just working them in detail just to make sure we have. Then over here, I have 10 minus 5 factorial. 10 minus 5 is 5. So what is in that parenthesis will be 5 times 4 times 3 times 2 times 1. Okay, so that is this. Yeah, that is this part. That's what we just did now, right? 10 minus 5 factorial is what we just did. So we're going to go ahead and do the remaining 5 factorial by the side. So if you take the remaining 5 factorial, then again you have times 5 times 4 times 3 times 2 times 1. Any question at this time? So what we just simplified is this item here. That's what we're focusing on now. That is what gives us this expanded simple form, right? And then I calculate a formula to solve these things very quickly, but we're just doing this to understand in detail what is going on. So now you've taken care of that. Of course, you can include the remaining part of the formula. So over here, you are going to include 1/6 raised to the power of 6. If you have a calculator that raises to power that has that function, do it. If you don't, if you have a 4-function calculator, you can still do 1, but this is reciprocal here, right? So that you can still do 1 divided by 6. That gives us this value. And you're going to multiply this value by itself 6 times. I think this stuff usually will have not seen anything. Okay, we could do a trick here. We could raise this to the power of 2. Right. Looking for a simple way to do this. Okay, so maybe if you have your calculator, just go ahead and do for us 1 divided by 6. 6 times. If you have a function to raise to the power, do that.
Not 0.0000128.
Okay, so 1 divided by 6 raised to the power of 5, right?
Yes.
0 point 0.00128. Is that
I guess it
correct?
would be 9, and it's 601.
Sorry, can you say that again?
So after that is 601.
6 zeros before 1.
No, it's
You said-
28601.
Oh, 0.006.
Then
Uh,
12608.
12608. Okay, so that should be, it
Or,
should remain
That's
6.
right. The 8's right. It's just 601.
She's saying the 8 needs to be rounded to a 9.
Yes. I didn't know how
Oh,
many to be
okay.
around.
Okay. Thank you. So this should be 9. This is what you mean, right?
Yes.
Okay. All right. So anybody got something different from this one? Okay. Let's go ahead and multiply. Let me use multiplication symbol here to make it different. Let's go ahead and do the remaining one. 5 divided by 6 raised to the power of 5, which again will be like 5 divided by 6. The result multiply itself. 5 times.
I got 0.402.
0.402. Okay. Anybody getting different value from these two? Most of the calculators you have should have a function to raise the power. It should be a common one. Yeah. Okay. So that will be. Anybody getting something different from these values? Okay. So we'll go ahead and finish up very quickly. So these ones here you can cancel out anyhow, right? I could start from 5. Let me use a black column. I could start from 5 and struck this off. And that goes away with this one, isn't it? And so the remaining ones, I can cancel it out anyhow I wish. Like I can use 3 to divide 6 here, 2 will remain. I can use that 2 here to cancel out this 2, right? Normally you don't bother about 1, right? I could use this 4 here to cancel out this 8 to give me 2. I could use this 5 here to cancel out this 10 to give me 2, right? So at the end, what I have in this section is, on this section, what I have left, you see everything underneath is gone, right? So what we have left is just 2 times 9 times 2 times 7. Every other thing else is cancelled out, right? Then the product of that multiplied by can you all help us do this one?
I got 252.
When you multiply all this?
Yes.
Okay, so I want to do it step by step so that way everybody see. So let me put that on the next slide. Okay, thank you. Okay, so you say when you multiply this, you got 252, right?
Yes.
Thank you. So let's go ahead and multiply these ones here, these two together. Just these two here. And we can do it together. So clear this, we have 0.000. 0.000129, right, times 0.402, right? And then we have that. So when we multiply this together, we have here, I'll be 4 zeros, then 519. So we have 0.000519. Right. So you're essentially multiplying this with 0.00005. So when we do this too, of your finance. So clear this. So we're gonna do 252 times 0.1234 divided by 5.9. Right? That gives us that. So we have 0.0131. 0.01. So this becomes something.
I got 0.0130 2.
0.01302.
I got where you got.
Yeah. Okay, so it will depend on so like over here, did you use as much as 519 on this line?
Well, I used so you know that you said there was the N C and then X. There's a function in my calculator to do that. And so I used that instead of doing all of that math.
I probably just did it wrong.
Yes. Yeah, so your calculator will generate the value to maybe 5 or 8 decimal places, right? So it's the rounding off that made that change. Okay, and this will occur from time to time. So what I would suggest you all do when you're working on questions for the class, right? Go ahead and use 4 digits, 4 decimal places, right? So if the number, no matter how long the number is, just use the 4 digits after your decimal points, right? But of course, sometimes you see like this one, you have 4 zeros already. So you don't want to stop at just 4 zeros, then that would be meaningless, right? Try to include ordinary number as much as possible. So it's the rounding off error.
Would I like if I did that like on the test, let's say, would it be wrong? Or would I need to do all that math?
So in the homework, the questions input, we normally say, leave your answer in 2 decimal places. Leave your answer in 3 decimals. Normally tell you where to cut your answer, right? Yeah. So what I would suggest is when you're working on that, and I know that none of them, I've not seen anyone that said leave your answer in 5 decimal places. The maximum I've seen is 4, right? It's maybe 3 or 2 or 1. Right? So if you're working with 4 digits always, it will keep you safe. So that way, when you're done, if it says leave it in 1 decimal place, you round to 1. If it says 2, you round to 2. But I've seen 4 at most. If we come across 5, then maybe we should increase it. But the general principle is when you're solving a question, work at least 1 or 2 decimal places above your final answer, right? So that you don't have a problem with rounding off error. And if for any reason you do this on the homework, of course, you have several trials. You can repeat it, right? But if it's on a quiz or a test, I would normally go back and give you credit for that, right? Because I know it's rounding off error. Okay. So any question on this one? Okay. So a common red flag in this answer is that, so if you know any function, there are about 2 or 3 functions, right, in the calculators. Even the factorial is also a function, right, in the calculator. If you know any functions to make this calculation simple for you during any assessment, go ahead and use it, okay? But I'm teaching just the basics so that make sure everybody is following. Okay, so that was a good one using a short platform. Okay, but it's also interesting to know that, I mean, this is what that function is doing, so that's good. All right, so a red flag to this question will be if I have a result that is more than 1, right? We know probabilities can never be above 1, it's between 0 and 1. So if I have a result that is 1, more than 1, say 1 point something or 2 point, then I know something is wrong with my calculation, right? Another red flag would be, of course, if I have a negative result. So probability can only be positive and the range is from 0 to 1. So if you have any result outside of this range, then that tells you something is wrong. You just calculate. Okay. All right. Any other concern or question about this? Okay, so that is how to implement that formula. And we are going to do B together, and then I will see you try C. Okay, so let's go ahead and solve B. B says, what is the probability in this situation that you have that 6 shows up more than 8 times, right? So let's go ahead and deal with that. If any of these colors I'm using is affecting you, just let us know, okay, so we can change it to one that. So we're looking for question, and we're going to solve question B, which says, what is the probability that 6 shows up more than 8 times? Right? So essentially, this is asking us to find the probability that that random variable is bigger than 8. And this, another way of thinking about this is that this is asking you, remember there are 10 occurrences. There are 10 10 throws of that die. So what is the chance that 6 shows up more than 8 times? Another way of saying that is to say, what is the probability that that variable is equal to 9 plus the probability that that variable is equal to the number of successes is equal to 10. Can you equate this to? You see that the right hand side is saying something as the left hand side, but the question was framed like the left hand side, right? But to solve it, you want to break it down like the right hand side. So what is the chance that the random variable, which is our 6 showing up, what is the chance that that shows up more than 8 times, bigger than 8 times? Since we know that there is a total of 10 true, there are only 2 occurrences bigger than 8 times, which is the 9, that 6 shows up 9 times, or 6 shows up 10 times. So the sum of those 2 will give you the probability. Remember last time we said all means addition. So this is like probability that 6 shows up 9 times, or 6 shows up 10 times. And that will mean the same thing literally as the probability that 6 shows up more than 8 times, right? The only 2 occurrences more than 8 times out of 10 true is 9 times or 10 times. Okay, I hope that is. So once you've got that down, then the other one is the same thing we've done before. So what do? You calculate the probability of these ones separately and then add them together, right? So the way we calculated the probability of 5 times, the only difference between what we have done here and what we are going to do is that in place of x, instead of having 5, you're going to have 8 now. Because, I mean, you're going to have 9, sorry. You're going to have 9 in this case, because you're looking at x being 9, and here you're going to have 10. Then when you solve those, you add them together, you have those. Okay. So we'll try to do this quicker now. Okay. So we have first one, the probability that x that 6 occurs 9 times, excuse me, will give us 10 factorial divided by 6, 10 minus 9 will be 1 factorial, isn't it? Then also have 9 factorial. So if this is confusing, let me know and we can talk about it. Then you're multiplying that with the probability of 1/6 raised to the power of 9 times the probability of Q of failure, which is 5/6 raised to the power of 1. Any question on this one? So if you do that, that gives you, so this is where you begin to kind of apply a simpler way of doing this. Like you can actually get this before the calculator function, right? If you look at this, you know that this is 10. You have a question?
Yes.
Yes.
So in the previous problem, we did both to the power of 5. So on this one, why is it 1 instead of 9?
Okay, so you know why we did put 5 here, right? Is that 10 minus 5 gives us 5,
Yes.
right? And there is 5, so this is n minus x. So 10 minus 5 gives us 5, and x is 5. So we have 5 here. That's why we have 5 and 5, right? At the
The
bottom.
5 and the x on the multiplication part of it, like the 1/6 to the power of 5 and then the 5/6 to the power of 5. And then why at the bottom did we do 9? And what
Right.
changes
So
that?
right. So we are plugging in for x.
Okay.
So in this question, x is 5, right?
Yes.
So over here you have p raised to the power of x, which is p raised to the power of 5.
Yes.
So over here you have q raised to the power of n minus x, and n is 10, x is 5, so 10 minus 5 is 5.
Oh, so it's 10 minus 9.
So here 10 minus 9 is 1.
Okay,
Yes.
thank you.
You're welcome. So at the bottom here, that is why we have 1 here, right? 1 factorial here, 9 factorial. Okay, so over here, This is supposed to be n minus x. This one. Okay. Any other concern about it? Okay, so I was going to say that if you look at this, you can easily tell the answer to this part, right? Can you see that? Like if you look at this one, you can easily tell the answer, isn't it? Without working it out.
It's 10.
To be 10?
Yeah.
Yeah. Right? Because you know that this will be like 10 times 9 times 8 all the way to times 1. And then you're dividing this by 1 factorial. Last class we said 1 factorial, so take note of that. 1 factorial is 1. 0 factorial is also 1. Okay, and I may add right now that anything raised to the power of 0 is equal to 1. Also, anything raised to the power of 1 is the same thing as okay, so these are key short things, that is easy to pick up and you solve question. Okay. So if I come back to this, knowing that 10 factorial on the numerator is 10 times 9 times 8 all the way to 1, knowing that on the denominator that this 1 factorial is 1. So you're dividing anything by 1 doesn't change, right? And then you know that 9 factorial is 9 times 8 times all the way to times 1. You can see that all of this could cancel out, isn't it? That just leaves you out with 10 on top. So if you get comfortable with this, you can look at that component of the formula and tell what the answer is. Just taking it down. Okay, so that will be 10 over there. Go back to problem. Okay, so if we go back to solving this now, we should have just 10 here times. So can you help us with the calculator now? Who wants 6 raised to the power of 9?
I got 0.7 zeros of 9.
0.7 zeros. Or right?
Yes.
And then 9. Thank you very much. Anybody else got something different from that or got the same thing?
Is that for 1/6 to the 9?
Yes.
I got 5.9078 to the negative 14.
You got 5.9
9078
to
to the negative
the
14.
negative 14. Okay. Anybody got something different from this one? From these two now. So we're looking at these two, either this or that.
I got the first one.
I understand.
You got this one?
Yeah.
Okay. And then we know how to represent this negative 14, right? So this would be like 14 zeros before you have your 5.9, right? So this, if we're going to write this out, this would be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it will be this way.
Oh wait, did you put your parentheses around the fraction? Like, did you do parentheses 1/6, close parentheses, and then raise to 9? Because mine did something weird the first time.
Well, I just divided 1 divided by 6 and then I put it to the 9.
Then you raise it to power of 9.
Yeah.
Okay. Alyssa, what did you do? Did
I
you
put
put
the
parentheses?
around 1/6.
You did 1/6 raised to the power of 9.
Yes.
And I'm trying to pick back your names again. Sorry, at the back. Who has got this? So somebody else, at least 2 people said they got
I
something
did
like
it
this.
the way she did it though and still got the same thing. So I don't know.
Okay, it's just calculated on there. So let's go ahead with this one since many people are doing that. Okay, but I was going to emphasize that when you see something like this, you know to write it this way, right? So this will be this. So this simply means the number of zeros before you have your actual digits. Okay. All right, so we're going to.
Is that a capital E? Is that what you mean?
So each calculator shows it differently. So yeah, for some of the calculators, it's written as t, meaning exponential. Yeah, there's some calculators to have it as it. Okay, so we're gonna go ahead and multiply this. And what about 5 divided by 6? So what would be 5 divided by 6 raised to the power of 1? You have to work in it. The same thing, right? Because anything raised to the power of 1 gives you exactly the same value. So that's good. So you will see that these questions could be solved without much work sometimes, right? Because of some of these shortcuts. Okay, so we multiply this out. What do we have? Somebody help us.
I got 8.269 power of -7.
To the power of -7. Okay.
I
Let's
got,
go ahead, please.
0.60 and then 825.
Okay, so you got 0.1, 2, 3, 4, 5, 6, then 8 to 5. And if you round out the 5, it will give you 6. Is that correct?
It would be 883 or 825.
Oh,
It
okay.
ends in 5.
Yes, of right. Okay. All right. Anybody has got something different from these two?
Did you?
Yeah, they are the same. Right. Right. So, and we talked about this before, right? So if you look at it, this will be e raised to the power of -7, right? That means 7 zeros, including the 1, count the 1 before the point, before you have your digits, right? So it's just the calculator simplifying the notation. But anybody has got something different from these two answers here?
Which way will our homework look? Like, whenever we're plugging it in for open math, will it want it in a decimal or like, should we round and do the top?
No, it will want it in decimal.
Okay.
It will want it in decimal. And there will always be a sub instruction underneath each way you're inputting your answer, telling you how the answer should be.
Okay.
But most of, I don't think it takes the notation. It's decimal. All right. So we are all agreeing on these answers here then. Okay, so and as we observe, both of them are the same. Okay, so it's saying the probability of getting just 9, right? So this is one component. You're going to repeat the same thing for 10, right? So let's try to do that very quickly. You repeat the same thing for 10. So the probability that our random variable comes out to be 10 instead of 9 will give us 10 factorial divided by 0 factorial times 10 factorial. I hope you're getting where that 0 is coming from, right? Times 1 over 6 raised to the power of 10 times 5 over 6 raised to the power of what?
0.
Power of 0. Right? Because this is supposed to be n minus x. So n is 10, x is 10. So this turns out to be 0. Okay. So bear in mind, I'm not writing the formula at the time, but you have that formula in mind when we are doing this, right? So this will be n factorial divided by n minus x factorial times x factorial, right? Multiplied by so the formula we are using is saying the probability of the random variable being equal to a given value is given as n factorial divided by n minus x factorial multiplied by x factorial times probability of success raised to the power of number of successes, right? Times probability of failure raised to the number of failure. Let me use the dots here too. Okay, this is slows us down, but it's okay, so let me use a dot here, right? So this will be q raised to the power of n minus x. Right. So if you look at this, that's what we plugged in, right? Underneath here, n minus x will be n is 10, x is 10 this time, x is 10, right? So 10 minus 10 gives us this 0 factorial. And then of course you have x factorial, which is your 10 factorial here, right? And then you have p is 1 over 6 raised to the power of x, which is 10, multiplied by q is 5 over 6 raised to the power of n minus x, so that becomes 0. Okay, so if this is clear to everybody, we're going to move on to finish this up. So over here, what do you think this will be, the whole of this?
1.
1. Right? Because now you have just 10 factorial cancelling out 10 factorial, you have 1. So this comes out easy sometimes. Then what should 1 over 6 raised to the power of 10? What have that value?
Oh, it's 1.6538 to the power of negative 8.
To the power of negative 8. So we just write negative 0, 0, 1, 2, 3, 4, 5, 6, 7. So what other whole number did you call, please?
16538.
16538. Okay, so let's keep it at 165. Anybody got something different from this? Okay, so what will be the last one? 5 raised to the power of 5 divided by 6 raised to the power of 0. 1. Okay, so have this shortcut somewhere in your notes. It's helpful, isn't it? So you see all this. Anything raised to the power of 1 is the same thing. Anything raised to the power of 0 is to simplify it. So over here, we have 1. So essentially your answer is isn't it? Because every other thing is 1, and 1 multiplying everything gives us the same thing. Right? Okay, so let's go ahead and try to finish up this very quickly. So tell us what will be the final answer here? Adding these two, right? So that we know that p of x being greater than 8 will imply p of x being equal to 9 plus p of x being equal to 10. And we've solved this and we find out that p of x being equal to 8 equal to 9 is 7 of that, 8 to 5 is 0.1234568 to 5 plus 0.1234567.165. So we're adding these together to get a final answer. Right, so this is 60, this is 7 here, so we should have this number come over here. So we have okay, let's start from the back. You have 0 with 1. Can you do this with calculator?
It is 0.60 and then 8415.
8415. Okay, somebody else check this very quick. You got the same thing? Okay. Why do you think the probability is so small? Is it realistic that the value we got at the answer here should be so tiny? Right? Because imagine getting a 6 9 times when you flip a die, 10 times. Imagine getting all 6 when you flip them. That is so rare. So the probability is expected to be very small. Right? Okay. All right. So go ahead and try the next one. Let me copy it down. Question number C. No more than 2 times. All right, so you're trying to solve this. No more than 2 times. Maybe I should copy the question down here so you can also look at this.
So would our x be 2?
Okay, so that is what I want you to think about.
Oh, okay.
Yeah, so, yeah, so think about it and see what you come up with. So this is the problem you're trying to solve. That's fine. I work with someone around you. Then if you got some answers, let's have them written down.
0.6137.
So let's write it right here. So first answer, I said
6137.
0.6137. I'm gonna start asking you all the names over and over again. Help me, what's your name, please?
Brenna.
Brenna, 0.6137. Okay. Anybody else got something different from this? And these answers are not meant to be correct, right? We are learning in class, so there shouldn't be any pressure about getting the right one or the wrong one. Doesn't really matter. Maybe if we get like two more different ones.
About 0.17 e to the 7th.
Okay, 1.7, right? 0.7
0.17.
e to the
Uh-huh.
7. Yes, right?
Yep.
Okay. All right. Thank you, Mike. Any other one? We need at least one more of an observation. Or if you are supporting any of these ones, kind of stuff. Okay, we are losing time. Let's work together and catch up wherever you are at the moment. And see first that you're on the right track, and then see if we can catch up with this. So, how would you describe this question? How would you describe no more than 2 times?
1 and 2.
Say it again, sorry.
Doing 1 and 2.
Doing 1 and 2. Okay.
Are you supposed to use?
Very close, but not very correct. You're supposed to do 0, right? So remember that is a common mistake. So, we're talking about 6 showing up. How many times 6 shows up? It's possible that you flip the coin 10 times and, the die 10 times, and 6 shows up 0. So 0 is a possible occurrence. So remember that always, when we started, we said here n. We blend it. Okay, so we said n could range from 0 all the way up to any value. Okay, so the probability could be represented this way. The probability that this random variable shows up no more than 2 times. All right, so it means the random variable could come, 6 could come up 0 all through 10th row, 1 times, 2 times, but not more than 2 times. Stop at. So we can represent it this way. And then if you break it up, then you're looking at this. So this is the 3 components you'll be solving to get that final answer. Okay, so let's do those very quickly. The first one will give us 10 factorial divided by 10 factorial times 0 factorial, right? Times probability of 1/6 raised to the power of successes is 0, times 5/6 raised to the power of 10. Right? So that will be the first one. Okay. Of course, all of this is 1, isn't it? All right, times all of this is also 1, right? And then this is just what we need to work. So 5/6, 5 divided by 6 raised to the power of 10. You'll help us with calculators.
Oh, it's. I got 0.1615.
0.1615. Thank you. Anybody got something different?
I got this.
The same thing. Okay, thank you. So this is what we have, and that is the final answer here, 0.1615. So we do the next one. Probability that x is equal to 1. Again, it's 10 factorial divided by 9 factorial, right? Times 1 factorial. I hope you're following with how these values are coming. So 1/6 raised to the power of 1 times 5/6 raised to the power of 9, right? So if we simplify this, we have, what do we have here? Just 10, right? And what do we have here? Same thing. So this is the only one we kind of worked on. So what is 5/6 raised to the power of 9? Divided by 6 to the power of 9.
0.19381.
Okay, thank you very much. Anybody got something different? It's something. Okay, good. So then we're going to go ahead and multiply everything out. So 10 times 1/6. 1/6 should be 0.0166. So if we multiply all this out, what do we have? 10 times 16 times 0.19381. 0.323. Okay, thank you. Anybody else got something different from 0.323 on this one? Okay, if that is correct, then we move to the last one, which is x being equal to 2. And so here you have 10 factorial divided by 8 factorial times 2 factorial, right? Times 1/6 to the power of 2 times 5/6 to the power of 8. Good. Okay, so if you do this, see what you have here. 8 factorial will go, so you have 10 times 9. 2 divide that will give you 5. So essentially you have 5 times 9, which is 45. And you confirm that this is okay?
Yes.
Yes. Okay, good. So we have 1/6 raised to the power of 2. Can somebody help us do that? 1/6 raised to the power of 2.
0.02777.
Okay, so we keep it at 8 over here times 5/6 raised to the power of 8.
0.2325.
0.2325. Thank you. Yeah, so the ways you are producing this number is fine. Just go as much as 4 digits. Okay, anything more than that will still be fine, not a problem. But at least up to 4 digits. Okay, so if we multiply all these out, what do we have?
I got 0.2906.
Thank you. Anybody got something different from that?
I got 07, like 2.907.
07, did you round it up to 7?
9648.
Oh, 648, okay. Okay, so these approximations will keep happening because of where we start somewhere along the line. Okay, so if we don't use all this, right, you'll get something started. So let's keep that way, it's okay. So we have 3 numbers here, this, and this, right? So that our final answer here, the probability that x is no more than 2 will be equal to the sum of those 3.
0.775.
Okay, just a moment. Let me write it all down for those who are following or who will be watching it later.
You add them all, right?
Yes, add 3 of them. So what did you get again?
I got 0.7751.
Thank you. Anybody got something different from that? Okay, so this is what you're essentially doing. It's the same thing, but so the only part you want to pay attention to is some of these things we listed here, right? Knowing these shortcuts will help you a lot, save a lot of time. or make your work faster. Actually, there is, I think there is evidence that if you work faster, you are actually more correct sometimes. Okay, not too fast. So, then pay attention to phrases like no more than, less than, greater than, equal to, and all those stuff, right? So we use the last 6 minutes to take care of this one. So we're gonna do it very quickly. Okay, the mean and the mean is also known as the expected value. Okay, and I could write it in word here. Mean is given with this symbol, right? Also called the expected value. Is given as n times p. Just n times p. Very straightforward. The variance is given as n times p times q. Just that, right? And the standard deviation, I'll use SD to represent that, is given as square root of the variance. You know that by now, right? So throughout this course, standard deviation for any particular thing will be the square root of the variance for that particular thing, all through the course. So if we're going to answer this question here, the second part, it says here, a retail store uses binomial distribution to model number of returns per week, right? Suppose that it is known that 12% of all orders get returned each week. Given that a particular store received 5,020 orders in a certain week, what is the expected number of returns? So when you see that expression, expected value, is simply asking you for the mean. Okay, so we're going to solve the mean there. So let me use purple here. So for question A, the expected number of return is simply asking for the mean. And the mean we know to be n times p. So you just multiply n by p. So 10, 20, 5020, which is your sample size, times n times p. What will be p here? Remember, p is the probability, right, of success. So what is p in this case? So success here will mean returns. When people return goods, it's a success for us in this description, right? So what will be the value of p?
0.12.
0.12 is very good. So it is in percentage this time, but it's probability. So somebody help us multiply this very quickly. Anybody got an answer there?
602.4.
602.4. Okay. So this is the average expected return. I hope it is correct, right?
Yes.
Okay. So this is the average expected return. But so if they got this value return, they actually got less than what's expected each week. Okay. Let's go ahead and finish up the other three. We still have 3 minutes, right? We'll be done, I'm sure. So the variance is n times p times q, right? So that is n, which we already have, 5020 times p, which is 0.12. What is q here?
Seven, nine.
0.79. It's not up to 0.8, right? Is it? So you're doing 1 minus 0.12, isn't it? So remember, q is equal to 1 minus p, right?
88.
0.88, right? Okay, so go ahead and multiply this for us quickly. What is the answer? All these three multiplied out. So it's just like saying this answer here multiplied by this value, right? Because you already did it.
530.112.
0.112. Thank you. So and the last one, of course,
It's
is
500.
530, not 5,000. Yeah. Yeah. So 530. 530.112.
112.
Thank you very much. So we go ahead and do the standard deviation represented by SD, just the square root of the variance. Right? So the square root of this value Please, as you're leaving, just mark before you leave your attendance. Okay, so if you find the square root, that is just the answer, okay? And the homework covers everything we've done today. Let's go ahead and see if we can finish it before we meet next time. Please mark on the attendance before you leave.